Trust is one of the most valuable commodities in the world. Without it, the computers and devices we rely on simply cannot operate. This podcast delves inside the concept of trusted computing, looking at the ways standards and specifications can keep you safe from attackers.
Hello, everyone. My name is Thorsten Stremlau, and I'd like to welcome you to this most recent podcast from the Trusted Computing Group. Today, we are here to speak to Chris Fenner, who is the co-chair of the TPM Work Group. And we really want to look at his experience and what he is doing within the specification for TPMs in order to drive TPMs to the next level. Chris, do you mind introducing yourself just briefly and I guess a little bit of background into your work at TCG?
Yeah. So my name is Chris Fenner. I work at Google in infrastructure security, and I'm also a co-chair of the TPM working group within Trusted Computing Group, together with Brad Littoral from Microsoft. My main focus within TCG for the past couple of years has been getting ready for post-quantum cryptography, but I'm kind of interested in everything that the TPM does and everything that people use it for. So I kind of do a lot of stuff along the way.
Oh, cool. Very, very good. Well, I guess, I myself am a long timer in this group. I actually started all the way in the beginning when, as part of a group within IBM, our main purpose was to replace smart cards. Right back then, that was basically it. When we think back to 1997, 1998, and the beginning of what was to become a TPM. Right, the technology was just bolt on. Right, there were these BIOS passwords and smart cards and dongles, and everybody was issuing their own little software crypto libraries all over the place. But there really wasn't one universal root of trust. And then what we were seeing is, the first emergence of like BIOS malware and key logging and all sorts of other things like it. And so, by the way, that then led to TCPA around 1999. And, it was a precursor to TCG. That then led to, the first publication of the TPM version 1.1b specification back in 2002, right? So that was, to give you a little bit of background, in terms of where we are now. Chris is new now to this and is bringing a completely new perspective, as he already said, as he's looking at, making sure that we are at state of the art, we're implementing and we're adjusting to the latest technology trends and security trends in this space. So I guess, Chris, I want to be very, very clear. While I've been, a part of the TCG from the very beginning, could you give us a little bit of an overview as the expert of the TPM in terms of, what does the TPM do? Can you give us a elevator pitch on what's important about it and what does it actually do?
Yeah. It's kind of slippery and hard to really pin down. So I would say the main thing that the TPM is really good at is just keeping track of stuff, which sounds like a pretty dumb and small and easy thing. But basically, the TPM is known as a root of trust for storage, and it's used to store both secrets as well as important measurements about any kind of running system that it's attached to. So kind of the first killer app for TPM is combining those two features into full disk encryption features like Microsoft BitLocker for Windows, where the key that's used to decrypt the rest of the boot disk is actually encrypted and stored within the TPM together with the expected measurements of the system. So BitLocker is configured so that the Windows boot disk is only decrypted if you're actually booting through legitimate Windows bootloader. If you're booting some other bootloader, that's fine, but you can't decrypt the Windows disk anymore. That's kind of the basic gist of what you can do with that. The TPM is actually able to do so much more than that, but it kind of ends up boiling down to the TPM keeps track of stuff.
And I guess, looking at that, how has the TPM evolved, I guess, from from, the beginning, right? In terms of a discrete, an integrated one, a firmware one, a virtual one. Could you cover a little bit about, I guess all of the different operational modes of the TPM and what you guys are looking at from a work group perspective?
Yeah, it's kind of interesting. You'll find TPMs in lots of places, and some of those places might be a surprise. So you mentioned like discrete TPMs, which might be the thing that you see a picture of when you look for the Wikipedia article on what a TPM even is. But really, at its core, TPM is an interface. So like you can talk to something somewhere that responds to TPM requests with responses and does what the TPM is supposed to do with that. So like, yes, you can integrate that into a small microcontroller that's soldered to your motherboard, and that's sort of what you think of as a discrete TPM. You can also integrate that into the system on a chip or a CPU in the board. Sometimes that's called like an integrated TPM or a firmware TPM. If you are a cloud customer, you might have a virtual machine, and that virtual machine might have a virtual TPM attached where the TPM is actually running in some kind of protected environment managed by your cloud provider. So really, it's kind of wherever you want to put it. We kind of have some names for the flavors of it. But at its core, the TPM keeps track of stuff, and it's something somewhere that can keep track of that stuff for you.
I actually love the very good explanation. Keeping track of stuff is actually I really like it, Chris. It is really, really good. So I guess, I'll go a little bit back from my perspective, a little bit of the history that I already alluded to, right? So, I want to focus on where we're going with this, which is where I started, right? Or, in the beginning. So 1998, 1999 were really the beginning seeds of this. It was the TPM was meant to be a low-cost replacement for smart cards and to prevent all these bolt-on things that were happening, right? So 2002, as I said before, the 1.1b specification really shipped and was brought in. 2003, then Trusted Computing Group was actually founded, right? So that was one of the things that was there as a governance body and to release the specification. It then took a couple of years when we released the 1.2 specification. And we added a couple of different things, in terms of the capability to store stuff, as you said. That's really, really good. And then, by the way, I think it was 2013, 2014, that's when we brought out the 2.0 specification. Now, that's the specification that you're still working with, right? So can you talk a little bit about what's happened since 2013 in terms of both what groundwork the 2.0 specification gave you, and then also, what that's enabled now from 2013 through to 2025, 2026?
Yeah. So as you mentioned, the TPM 2.0 specification came out in 2013, 2014-ish, depending on which revision you're talking about. And it kind of gets to stand on the shoulders of TPM 1.2 and take advantage of a couple of really key learnings. So I would say the first key learning from TPM 1.2 was like, there's no such thing as endgame crypto. Like whatever is the latest and greatest thing that you think is awesome and gonna last you forever, it's not. Don't worry. So TPM 1.2's choice of endgame crypto was SHA-1 and RSA 2048. And well, SHA-1 is broken and was dying in the early aughts, and RSA 2048 is not broken, but quantum computers are trying to kill it. They're doing their best. And also we have many other sizes of RSA keys that we like even better than 2K. So it was really clear that a new version of the TPM specification needed to be created in order to handle the fact that crypto changes. Like we call this crypto agility. The other really cool insight that I think TPM 2.0 was successful at was the idea of having a reference implementation. And like we're pretty decent at writing specifications and writing English text that describes what a machine should do. But really the best way to describe what a machine should do is code. Like that actually tells the machine what it should do. So TPM 2.0 from the very beginning came with a reference implementation that said, here's essentially an implementation of the whole spec. You could just grab it and modify it as you need and use it to build your products. And that drove a lot of really good alignment between the various implementations of the standard and made it a lot easier for consumers, such as operating system vendors and people building tools and people trying to protect their environments, to expect, kind of standard uniformity across vendors without having to deal so much with kind of like vendor specific issues. So going into 2013, 2014, that was kind of the two big goals of 2.0. That's around the time that I got introduced to trusted computing. So I was an intern at Microsoft in 2013, and I was working on this stuff, and it was all brand new at the time. And I had no idea what I was getting into. I didn't realize that I'd find like the vocational passion for the rest of my career. But I just fell in love instantly. Since then, TPM 2.0 has been kind of moving forward gradually, adding some pretty cool new features. So we've had several revisions of the specification since then. So the most recent one is called 184. It was published in March of 2025. And the next one, which is available for public review now, is called version 185 and introduces some of the post-quantum crypto algorithms that you'll see for kind of the next generation of cryptography. So along the way, we've been able to just add more stuff into TPM 2.0, add new capabilities to it, basic non-breaking feature add changes. So that's how it's been able to stay TPM 2.0 for over a decade at this point.
Yeah, cool. I do remember that making it more agile and also more adaptable was one of the things that way back then in 2013, 2014 was one of the things. Well, and also one of the reasons why it took so long to get from 1.2 to 2.0. There were a lot of discussion that we went through at the time. Now, so you talked about 194 and 195, I guess, from the latest revisions that we've brought out. Could you talk a little bit about, I guess, from a work group perspective, as you're looking through these new revisions, again, similar to 1.2 to 2.0, how do you balance, certain, complexity of the TPM, cost of the TPM versus being able to be more agile and adding new features like crypto primitives and all sorts of other things like it. Can you talk a little bit about what types of considerations you take into account and how you look at those things from a work group perspective?
Yeah, that's a really good question, and that's actually the thing that I think is the most interesting about standards, is that you've got a whole collection of people from all different backgrounds and different jobs trying to haggle over these things. So in the work group, obviously, we've got people who build TPMs, and we've got people that use TPMs, and we've got people who really believe in TPMs, and we've got people who, really want other people to use TPMs. So it's kind of a mix of people with use cases and people willing to satisfy those use cases. And so another sort of key structural thing about TPM 2.0 is that it's called a library specification. So it's kind of like a buffet. Like, it's got a lot of features in it. And really, in order to have a TPM, you don't have to implement that many of the features. Philosophically, you could have a whole argument about the smallest possible TPM, right? But I think if you at least implement one TPM command and you implement something that you call a platform specific TPM profile, you're a TPM. So one of the ways that we're able to add features without burdening everyone ever all the time with everything is we'll add features to the library specification, knowing that maybe some people will implement it and some people won't. So you'll find TPMs inside PCs, inside laptops, inside servers, inside cars. Like, those TPMs may or may not be the actual same physical hardware, and they may or may not have the same physical capabilities, right? So when we add stuff to the library, we're saying if somebody were to implement, for example, MLDSA, this is what it means to implement that algorithm. If you can't or don't want to implement that and your profile doesn't require you to, that's totally fine. So that allows us to have conversations that are, a little more hypothetical. We can say, all right, if we implemented this, if somebody implemented this, what would it look like and how would it work? And we can argue about that without arguing about whether to make everyone do it or, that's a much more difficult topic.
That's good. So Chris, and by the way, you mentioned, for example, quantum computing and PQC there in that last answer. Could you talk a little bit about, I guess, how you're looking at quantum computing over the horizon from a TPM work group perspective?
Totally. Yeah. So two things that are true about quantum algorithms. One, they take up a lot more space and they're a lot more complicated. So that's just tough for the embedded world. For example, an ECC key might be like 100 bytes or less. An RSA key, we're talking a few hundred bytes. Post-quantum keys tend to be in the like 1 to 5,000 byte range. And that's really just the start. It's probably going to get worse over time. The other thing that's true about quantum cryptography right now is that it's rapidly changing. So last year, NIST standardized sort of the first round of new algorithms for post-quantum cryptography. So they're called MLDSA, SLHDSA, and MLChem. All these algorithms have pretty big key sizes, pretty big ciphertext signature sizes. These are actually sort of like the small ones to come. I think we can expect new standards to come out, maybe a little smaller, but mostly bigger over time. And so I think every year or two or a few years, we can expect there to be more algorithms on the scene, especially as the mathematicians get their teeth into it and publish new papers about things. That kind of the name of the game is agility for now. When we think about that from the TPM perspective, the first thing is like, we got to be able to keep up with this stuff. So the first thing we did when really committing to post-quantum crypto is we took a good look at the way that we do the work that we do and how we do it and how we collaborate and how we can streamline that and make it more efficient. So we've adopted a process internally that's based on GitHub and Markdown. So basically we send each other pull requests against the spec and review changes kind of like code. We just borrow a lot of tools from coders. Coders have been working in teams to work on very large documents for a long time, and they're pretty good at that collaboration process. And so by adopting those tools, we've been able to pretty radically speed up our ability to decide on new things, publish new versions of the spec, and keep up to date with the crypto. And then the next thing that we've done, and this is what you'll see in the public review version of TPM 2.0 version 185, is add just two new algorithms and sort of the infrastructure required to use those algorithms. So those algorithms are MLDSA, which is a signing algorithm, and MLChem, which is a key encapsulation algorithm. And you can think of that as an encryption algorithm.
Very, very good. All right. So last question for you, Chris, before we wrap up. TCG has courses on to train students on the TPM. Can you talk a little bit about the OST2 offering, and I guess what your point of view on that is?
Yeah. So kind of an unfortunate property of something as cool as the TPM is that this learning curve's a little steep. Like the spec is something like 900 pages, and it's kind of difficult to just crack open and learn about right away. So there's some really good books that you can read that I could recommend. But we also have this new training provided by OST2 that is like an interactive online course for learning about the TPM and learning to use the TPM. Because I think the more that you can engage with the TPM from that kind of technical sort of software engineer kind of level, like you're talking to like a remote procedure call kind of service that can respond to requests, and you can do some stuff and maybe dynamically respond to those responses. Like that unlocks a lot of power within the TPM. So I highly recommend that people who are interested in the TPM take a look at that and engage with those courses. They're free and they're really good. Another thing that you can do is just pick up a TPM software stack. So a client library that makes it easier to talk to the TPM. So Google maintains one for using the Go programming language to talk to the TPM. I'm a maintainer for that. You'll find software stacks in other languages like C and C++ and C#, Java, all over the place, right? Like whatever you need. I strongly recommend just picking up a simulator and just messing around. What if I made a key, and what if I used it to do something? It's kind of addictive once you get started. Like you'll find some pretty neat thing that you can use the TPM for.
I think it's, from what you said here, is evident that the TPM remains essential to device security, and it will also continue to be really, really important in the future as well, especially as we look at, the emergence of new threats in this space. For those of you listening to this podcast, in our next episode, we'll be covering the emergence of smaller devices such as, mobile phones and tablets, and then how these present a new challenge to standards bodies like the Trusted TPM Group. All right, so thank you again, Chris, and tune in next time to learn more.
Thanks for having me on the show, Thorsten.